So the program says that during the regular execution, I have faced an invalid condition, and I am quitting the regular flow. I am giving you the exception object. You have to decide what's inside the exception, and you have to look at the details. So you might have already seen it in your programming time that there are few basic types of exceptions, like a null pointer exception. You may even see a divide by zero exception. So I will first simulate an exception, and then we'll talk about how we can handle it. So today also I have created all the projects in my own time, and I will just walk you through the code. Let me know whenever you face a problem, and I will discuss it into more details. So I will share these projects with you, so don't worry, you can take a look at it. So as I was talking about, there is an exception type called divide by zero. So this is an exception when an invalid mathematical operation happens, and that operation is divided by zero. So as you know that in mathematics we cannot divide anything by zero. So whenever we try to do it while in our program, it will throw up. It will say that there is an exception, and the regular flow of your program will terminate. So this is a small method that I have created inside the exception theory Java class. All the methods are static methods, so you don't have to create an instance of the class. You can just directly access them. So in this method, you will see that all I have done is created an integer object and assigned it a value 0. Then I have created another integer data type, and I have assigned it a value 12. I have assigned it a value 12 by A. Now A, as the value is 0, it will throw up. It will give me an exception. So in different IDEs, you will find a different way of representing the exception, but the basic information will remain the same, because exception is a Java specific class. I mean to say, the exceptions in Java are very much specific, and almost on all the IDs you will get the same exception. So divide by zero exception. You will see that when I run this program, if I do a run, you will see that on the console window I directly get a divided by zero error. So it says that exception in thread main, and you will see that it has quit the regular flow of the program, and it has just thrown the exception. Now it says that it is an exception of java.lang.arithmetic exception. Now this is the package. Java.lang is the package, and inside the package there is a arithmetic exception. Now it clearly gives you all the information that it is divided by 0, and it will give you where it occurred. So you will see that it gives you the flow in which the program flow where the exception occurred. So it says that the exception occurred at test.exceptionTheory.divided by 0 exception method, and it occurred at line number 13. If you double click on that, it will take you exactly to the place where the exception occurred. So it took you to this page where you know that, yeah, line number 13. If you go to line number 13, this is the line number 13. You can see it here, and it tells you that here I found that exception. So now this was a case when we did not handle it. Now in runtime you can get any kind of exception. So in Selenium, the most common type of exception is the no such element exception, where it says that I am trying to find an element, and there is I wasn't able to find the exception, find the element. So in that case, it will throw a no such element exception. So if let's say we were to design a robust, a very reliable system, in that case we will have to counter for those kinds of exceptions. We have to counter for runtime exceptions. So the basic way to counter an exception is to provide a try catch block. So try catch, in the try block you will put the statements which you think can throw an exception, and in the catch block you will catch the exception. So what will happen, so if I go back to the previous example, what happened is that at this line the program found that there is an invalid condition. it terminated the regular flow and it threw an exception object back to the caller of this method. So the caller of this method was the main program, the program main. So you can confirm this here. It says that test.program main.main method called up this method. So this is in a sequence. Here the caller is present and here what function was called. So that method will throw an exception back to the main method and the main method will terminate. But let's say I don't want to terminate the program. I want to move ahead with it. So in that case, what will happen? Just a minute. In that case, what will happen is that I will put the statements which I think can throw an exception in the try catch block. In the try block, the statements will go. In the catch block, I will catch the exception. So here, I know that this will throw an exception, b equals to b by a, because a is a 0. So what I will do, I will catch it. And in catch, so this is the basic syntax. In catch, I have to specify what kind of exception I want to catch. Now all the exceptions have a base class called exception. You will see that it is java lang.exception. This is the base class. All the exceptions are inherited from this class. So I will say that I just want to catch exception. This means that I will catch all the exceptions that will ever be thrown by this method. So whatever the exception will be, it will be caught here. So once I catch it, I can do anything inside the catch block. This is the catch block, starting by the opening curly braces and ends with the ending curly braces. In this, you can choose to print the exception. You can choose to do a recovery step. You can choose to direct the flow of the program to some other method which can handle, which can change the flow of the program. So now the important point here is that this is the exception object that I have caught from this method. Now this exception object comes up with inbuilt methods, and it's actually an object, so it will be obviously be storing some data, storing some information inside it, and those informations are more related to what the exception is. So you can see that there are so many methods, right? So you can use any method and you can get more information about the exception, and you can, so the main reason you can do, you will try to do this is to log it in a log file and later on analyze why the exception came up. So you can see that there are methods like print stack trace. Then there are some methods where you can get the class, of the exception, and you can get the localized message, you can get the message. So you can go through all these methods and you can try to figure out what they tell you more about the exception. I have just implemented a few methods. So here I am trying to get the class of the exception to determine what kind of exception it was, and I'm trying to get the message. I'm trying to get the localized message, and I'm trying to get the stack trace as well. And here I'm printing the stack trace. So this method will print the complete stack trace. Now what is a stack trace? I think most of us are already aware of it, but the stack trace is the sequence of calls that happened in your program. So in our program, what happened was that first the main method was called. After the main method, we called the divide by 0 exception method inside the exception theory class. So it will be shown you in a structured way. So this is the structured way. The most recent caller is shown at the top. Recent caller or the called function is shown at the top, and after that the least recent one. So this is in an order from the most recent to the least recent. So you can see that, you can see the program flow from here, and this is called a stack trace. It tells you more about how the call flow went. Now stack trace also consists of other information, but yeah, for the time being we can consider this as a stack trace. So let me just run this method, and you will see a difference in how this time the program runs. So I will put a simple statement out here to show that the exception will, after the exception, the program will continue to continue till the end. So I will just do this this print. So I will run the method again, I will run the program again, and you will see how it shows. So it says that an exception was thrown, because that is what we tried to catch earlier. It says that an exception was thrown, and it will give you more information, like the class name of exception was class, and it will tell you that what was the exception type, what was the exact class name. So it is a arithmetic exception, and it resides under java.lang namespace. After that, it says the message in the exception is divided by 0. So you can use this message to take some actions to recover. The localized message is divide by 0. Then the stack trace is this one, and if I want to print the stack trace, this is the stack trace which was printed by exception.print stack trace method. Now I have caught this exception. That's why we reached to the end of the program. So this is how we catch exceptions. Yeah, do you have any questions in that? Is everybody clear about it? All right. So the basic idea is this block. Wherever you find, you think that an exception can occur, put it inside a try block and catch the exception. And well, this is how we catch an exception. Now, what we can do. So here you can see that we have caught the base exception. We have caught all the exceptions that were present that can be thrown. But we can also have specific exceptions that we can catch. So in the same example, I have created another method which is divide by 0, catching specific exception. In this method, what we have done is we are trying to just catch a arithmetic exception. So if any other exception occurs, let's say there is a runtime exception, or let's say there is a access denied exception or a memory read exception, in that case we won't be able to catch those exceptions. We will just be looking for the arithmetic exception. So what will happen is that it will again come to this statement. It will throw an exception. If the exception is of arithmetic exception type, it will catch it, otherwise it will throw it. It will throw it back to the caller. So if I run this method, you will see exactly the same thing. You will see that I was able to catch the exception. I was able to print out different specifics of the exception, and I was able to reach to the end of the program. But in this case, there is one very small issue, is that let's say there was any other kind of exception. Let's say, don't worry about the statement that I am putting right now. I will explain it to you. Let's say there was some exception, some other exception that was thrown, and I will put it just above my arithmetic exception. So in this program, what will happen? Yeah. In this program, what will happen is that, well, yeah, it's not allowing me to because this is unreachable code. So what I'm trying to do, I'm trying to throw a new exception. I'm trying to throw a random exception. It's actually a custom exception. So I will throw this exception, and what we are trying to see is that this exception is not caught by this block, this catch block, and the program execution terminates. So I can show it to you by this. If I run this block again, you will see that it throws an exception. It says exception in the main thread, and it's a divide by 0 exception, and the program never reaches the end because it was this exception was not caught. This is a specific exception. Just give me 1 minute. There is a problem in my connection. Just give me 1 minute. I'm sorry for that. Actually, there was a little problem. So as we were talking about exceptions, you would see that here we haven't caught a generic exception. That's why any other exception apart other than arithmetic exception will not be caught, and the program execution will terminate. So this is important because we might end up catching the wrong exceptions, and we end up in terminating the program prematurely. Any questions till now? All right. Yeah, Kunal.
Yeah, as you mentioned that we'll be catching exception more oftenly when we have to identify an element and make that to perform any operation. So
Yes.
does that mean that for every click, do we need to write this try catch block? For every
yeah, I'm sorry, please complete your question.
Yeah, you got the question actually. So
yeah,
I just want to know that how do we handle each operation on a web page? Do we need to have this try catch block all the time?
No, so we don't need to have try catch block all the time. There are ways to create just one method where there are ways to wrap around your action statement. For example, on an element you want to click on something, so you might create a function where while clicking you will first validate whether the element is present or not. If the element is not present, you won't even try to click on it. So there are ways you can write methods around it, but we have it coming in the classes.
Okay.
So we don't have to write this try catch in every statement. We can wrap it around a function and use that function instead of it.
Okay, yeah, got it. Thank you. If it is coming in next session, then it is good.
Yeah, it is coming. This is a
this is Srini. I know you have used here arithmetic exception, and just it's because that you have seen in the previous example where you got that arithmetic exception. That's why you're catching that to show us an example. But in real time, how do we know that which exception that we need to catch? I mean, how to catch? I mean, which exception that we really need to catch? I mean, it doesn't have to be like like say in this example you got an exception, so you have shown us this thing, but like if I'm doing some sort of testing, how do I know which I need to catch and track?
Yeah, well, that's a real good question, and I will show you how it works. So in your while you are designing your system, while you are programming your methods, you would perform a certain type of steps, right? So let's say instead of arithmetic operations, you were trying to connect to a network, to a server. So in that case, you would know that yes, I might get some of the exception from the network exception package. So all the exceptions like server not found, connection ended prematurely, these kinds of exception. Now, in those cases, you will know that these are the kind of steps I'm trying to do, and I will try to catch these types of exceptions because while in a network connection procedure, I might not get an arithmetic exception. This is how you decide what kind of exception you want to catch. Now, the point comes that let's say while connecting to a network, you have 10 different types of exceptions. Then why would you write a catch block every time for any exception, right? Let's say there are 10 exceptions in network domain, so you would write 10 catch blocks, right? But that's not feasible, and that doesn't look good. So you will find that there would be a very lengthy catch block, and it's not a good programming practice also. So the reason why I chose arithmetic exception here, or let's say any other type of exception, why I will choose that is because I want to perform something additional when that type of exception occurs. So usually what happens is that, let's say there is an arithmetic exception. So what you will do, I will say that I want to recover my program here. So I will write my steps to recover here. But I will say that, okay, if there is any other type of exception, let's say I will just do a simple plain catch exception block. I will say that in that case, I will not even try to recover. I will just log it. I will log my exception, and I will move forward. So this is how you decide what I want to catch. So whatever exception are really important to you and you want to do something extra in those exceptions, you catch them. If let's say there is nothing extra to be done here, I will just catch a generic exception and I will move ahead by logging it or probably terminating the program. Was I clear?
Yeah, you're right. So in other words, whenever we're designing a class, it's better practice to see the first error and go into that direction. So which exception you want to catch, really, isn't it?
Yes. So while designing your system or a class or a method, you would look for the exceptions of your need, like whatever exceptions that you are interested in. So you will find those exceptions. You will implement your code flow based on that. And for all other generic exceptions, you will just have a generic way of handling them.
That's right. Thanks. Thank you very much.
Yeah. Any question?
Yes, I have a question.
Yes, Erwin.
Here you are handling arithmetic exception. So you have written inside catch, you have passed the name of the exception as one of the parameters. Suppose if I have to handle 10 exceptions, how will I write it?
Okay, so well, in case you have to handle 10 exceptions, then it has to be 10 different catch blocks.
Okay.
Each catch block will have only one exception.
Okay, understood.
But again, the same question comes when you have like 10 different exceptions, then probably you would like to group them together. You will catch a generic exception, then okay, so I will write some more code here. Just follow me in this code, and in case you have a question, just let me know right away. So let's say I have 10 different exceptions and I will group them together. Let's say for the first 3 exceptions I have to perform something. For the next 3 I have to perform some other thing which is common to those 3 exceptions. So what I will do, I will catch a generic exception and I will write a if statement, and in the if statement I will say dot get class. This will give me the type of exception, right? So I will say, let's say this class has a name, no such element, right? So actually this exact syntax won't work because you will have to do name get class and then get canonical name. So so what I mean to say here is that you have to do a name. You will find the name or the class of the exception, and you will say that if it matches any of the 3 contains, let's say contains no such element, I will take from here, I will say that I will take action 1, else if let's say the exception class has some other name, for example arithmetic exception 1, let's say it has a arithmetic exception, I will do another set of actions. So let's say action 2. So this is how you will just have one catch block, but you will perform different actions based on the exception that you have. So either it's quite a lot of if statements or it's quite a lot of catch statements.
Okay, yeah, understood.
All right. Any more question? All right. So I think Snehal is not able to hear us. Well, yeah. All right. So moving forward, I will take you to the next example where let's say, so these are, before going there, let me just show you. So in java.lang, in this package you have quite a few exceptions. So the first one is the base class, which is exception. The other one is arithmetic exception. Then you have array index out of bound exception, which happens when you are trying to access the element inside an array which is not present. So let's say an element is of size 5 and you are trying to access element at position 6. So as it is out of the bound of the array, this exception is thrown. Now these are the standard exceptions that you have. These are the exceptions provided by the Java runtime to you. Now let's say you don't want to use them. You just want to have your own exception. For example, while clicking an element in Selenium, what happens is that while clicking an element, the element was not visible, or let's say the element was not clickable. In that case, I just want to throw some of my custom exceptions. For example, I want to throw that element is not clickable, and I want to pass some other information to it. So I will use my custom exception. Now to use a custom exception, you have to inherit the exception base class. So we had discussed the concept of inheritance. So after inheriting the base exception class, I can create my own exception. This is one way of doing that. The other way of doing that is by creating a base exception but providing your custom message to it. So I can say that whenever I get a failure step, I just want to throw an exception, and that exception has a message which says something really meaningful. In this case, I have just shown a simple exception. In other cases, in real life examples, it might be more meaningful. Let's say the element was not clickable, the element was not visible, or the mouse drivers failed. So that could be anything. So this way you throw an exception. Now throwing an exception again does the same thing. It terminates the program execution and it throws the exception object back to the caller. So in this case, if I run this method, the caller would be my main method. So this method divided by 0 throwing custom exception back will throw an exception which will be of the base exception type, but it will have a message, a simple exception, and it will throw it back to the caller, which is the main method. So if I run the program, you will see that it will terminate and it will just give me a custom exception. So if I just run it, you will see that it caught the first exception which was divided by 0, but after that it threw it again. It threw a new exception again, and you will see that the base class of the type of the exception is the base class, which is java.lang.exception, and the message is a simple exception, which is what we wrote. So here I can even say a simple exception from my side, and when I will run this program, it will say that yeah, we received an exception which was a simple exception from my side, and it was of type the base exception type, java.lang.exception. So this is how you throw back the exceptions. Now throw is the word, throw is the keyword. You use throw to throw the exceptions back. Now if this is how you throw the exceptions back. So you might use these kinds of constructs while writing your Selenium tests, because at times you just want to quit from any further execution, so you throw the exception back. But at the same time, you want to log more information. So just before throwing the exception back, you do your diagnostic and you do your logging part, which I have done here, and then you throw the exception back and the program terminates. So a typical example in real life would be, let's say you try to run your tests on one particular environment, test environment, and somehow that environment is not working, or somehow that environment is throwing a 404 error whenever you try to open a page. In that case, what you will do, as soon as the exception is thrown, you will catch it, you will perform your basic logging actions, you will perform your diagnostic steps. For example, you would like to query the server, get more information about the state of the server. You will get that information, you will log that information here only, and then you will tell your main program, the test runner, that yes, we have faced an exception, switch off all the system. So it will just stop executing and you will get the relevant results. So this is how you catch exceptions, and this is how you handle exceptions, and this is how you throw back the exception to the caller. Any questions in that, in these 3 topics? All right. Alright, we will move on to the next topic after this. The next topic is related to Selenium. Now, what happens when you try to find an element on a web page which does not exist? In that case, we get the exception called no such element exception. This exception is situated inside org.openqa.selenium namespace. So whenever you try to perform an action on an element and you know that this element is a tricky one, sometimes it appears, sometimes it doesn't appear, and these kinds of elements are present mostly in AJAX calls. So sometimes you can get this element, sometimes you don't get this element. In those cases, it's always advisable to catch the exception so that you can move ahead with the program and just log that the element was not found. So I will show you a simple example on this where we will throw an element not found exception. So I have again created this program where I have whatever I'm showing you right now is present. So don't worry about it. Just go through the program if you're not able to get through it right away. But if you get any questions, just do ask me. So let me get you the element not found exception. Okay. Well, I think I'm looking at the wrong one. So I've moved it across different projects, so probably. Okay, so we are not able to find it in our project, but what I will do, I will quickly write it down. So let's say in the element find strategy, we have one method where we try to find an element. Let's say public static. And in this, I will pass on a driver and I will pass on the locator. Locator is the attribute which you will look for. So I will pass it on. I will try to ask the driver to find it for me, and I will say that let's say the locator is of type ID, and I will say that just find it for me, locator. So let me run this method from the main program, and we will see and we have our find element, and before that let us navigate to a page. This is the page. So you must be aware of these statements because we have worked on these in our earlier classes. So you will see that here I am creating a Firefox driver and I'm moving to this page, which is I'm navigating to this page, which is our test practice page. So you will find quite a few practice elements here, so you can practice on that. Let's say I'm trying to find this element, which obviously wouldn't be present. So if I run my test, you will see that there would be an exception that is thrown, and this part of the program will not be executed. So I've just run the test. It takes quite a while to open the Firefox browser, and I have opened the console window. So it will open Firefox browser, it will navigate to a page, the page that I have shown, and it will try to find the element by ID, and the locator name is some weird name that I have given, and you will see that it won't be able to find it. As soon as it it is not able to find it, it throws an exception. And you will see that the exception type is, let me enlarge it. So the exception type is element not org.openqa.selenium.no such element exception. So this is the exception, and this exception gives you lots of other information. So it says that it was unable to locate an element, and it says that the search method was by ID and the selector was this. So you will see that this is the locator name that I had given, and I asked it to search by ID. So the exceptions are very useful in itself. They give you lots of information, and it will also tell you that the command duration or timeout was 70 milliseconds. And well, Selenium has also passed on a couple of information to the exception, which is if you want to search more about the exception, go to this page and it will give you more exception. Plus, let's say you want to log more information. Let's say you want to know what Windows version it was, what computer architecture it was. So it will give you all that information. It will say that the build info, this is the IP address, this is the OS version, and here you go with the other information. So this comes in handy when you have like version with new versions of browser and Selenium coming. You might get into situations where you are getting unexpected exceptions. So this information will really help you out to identify on which platform, on which version of Selenium drivers, and on which version, Java version, the problem was coming. So this way it's a good information to debug. So this is the exception. This is the element, no such element exception. Now let's try to catch it. If I go back, so this is this was the method where the exception came in. So as we looked at it earlier, all I have to do is just put a try catch around, and you will see that I can catch the specific exception. I will say that I want to catch openqa.selenium openqa.selenium.no such element exception, and I will say exp, and I will log this exception, and I will move ahead. I will say that okay, that's fine. If I'm not able to find this element, that's fine. I will log it and I will move ahead. So this is how you will catch the exception. And I will move ahead. So if I run this statement again, this method again, you know what will come up. So I will just skip this part. I will move on to the next topic. So any question on element not found exception? All right. Yeah, Usha,
I
you have
had
a
a question.
Yes.
Yes. See, here we were looking for something like element not found, no such element exception. But in my test cases or my test scripts, it is required for me to actually check that element. Maybe I'm trying to click on it, right? But for some reasons, I am not able to find that element. So it does not make sense for me just to do a exception handling and move ahead further, because that's a basic thing for my test script to test. So in that cases, how do we handle it?
Okay, so in those cases you have two options. The first one is you ignore the exception. You don't actually catch the exception. So you will eliminate this part and the try block. So in that case, what will happen is that your test will fail, but it will fail the whole test execution. It will say there was an exception, and if this exception is not caught at the test runner level. So what will happen is that we'll throw an exception, it will quit the test and probably move on to the next test. Right? This is one way of handling it. So while it quits the test, your logger will get the exception and it will log it. Right? The other way is you catch the exception. Let's say I caught this exception. I said that element was not found do these things, right? Let's say there were n number of methods that you want to call, for example, generating a report or logging more detailed information, logging the OS version and everything. You can catch it, you can log the information, and you can again throw. You can just write the throw statement. So throw the same exception actually. You can throw the same exception back. So what you can do, you can either choose to catch it and do whatever you want to do, or you can leave it the way it is and let the system do the regular work, like logging the exception and terminating. So these are the two choices that you have.
Okay, so if the test case fails also, how would I draw a conclusion that it was a valid failure, or as because we were seeing here, because it's no such element exception that we're trying to see, right? So anybody, if I'm trying to produce a report, if I'm trying to say that no such element exception occurred because of which the test case failed. So how would I draw a conclusion that this script failed because of a valid failure, or it failed because of I not doing the necessary action? I hope I'm making sense.
Yeah. So yes. So basically, you need more information. That's what you need to do, right? So here, what you can do. So this step said that I wasn't able to find the element, right? So what you can do, you catch the exception, right? You catch it. You write a method to take screenshot. This will give you the screenshot of the page at that point. Then what you will do, you will write a method to dump the page source. In the last class we talked about page source, so you will dump the page source, and after catching the exception you will also dump the server logs, let's say, and this would be quite a good amount of information for you to determine whether it was a failure in your test, the way you wrote the test, or probably it was because of the runtime failure. So by screenshot you will be able to find that, oh, the element was present, but somehow my script wasn't able to find it. So you will go back into your script and you will try to debug it where the problem is. Let's say the element was actually not present, so you have just found a defect, so you will log the defect.
Okay. Yeah, that makes sense. Yeah, thank you.
Yeah. Any more questions? Okay. So we will move on to the next topic. So now we are clear about no such element exception. Now, as an exercise, I will give you the list of exceptions that are here. You can see a lot of exceptions, right? They are like huge number of exceptions. Element not visible exception. When the element is not present in the viewport on the screen, it might be somewhere down, or probably it might have not been loaded at that point in time. So element not visible exception, an invalid element state exception. So this will occur when you're trying to click on an element but the element is not visible or is graded out. So this is the exception that you will get. Similarly, no such frame exception, no such window exception. So you can write down, just to understand exceptions better and just to understand exceptions in the context of Selenium, what you can do, you can try to write down these tests, and in those tests try to simulate these exceptions. For example, stale element reference exception. You might want to change the web page and try to access an old element, so you will get this exception. So just try to look around these exceptions, and if you have any questions, just drop us an email or ask a question on forumsqa.com, and we will get back to you on that. So all the exceptions cannot be covered in this class, so I will just skip them up, and we will move on to the next set of topics. Before that, yeah, okay. So moving on to the next topic. So we just covered element not found exception. We will use it in our later exercises. We had covered exception and handling it. This is the try catch block we were talking about. We can, so here we are talking about throwing the exception back to the caller. And here we are talking about creating a new exception. So just go through the slide, go through the video again and get more clarity on it. So after that we will move on to CSS selectors. So in the last class we were trying to find elements based on the methods provided by the Selenium WebDriver class, WebDriver interface. So let me just open that class first. I have created a separate class which is the CSS selector Java. Now this is very important. The first reason why CSS selection is very important, and the first reason why you should know about CSS selectors, is because in most of the cases, in most of the browser, this is faster as compared to your XPath way of finding the elements, and this is a way which is not so dependent on unique identifiers. So you should know about it, and whenever necessary just use these methods. So as CSS selector engine is implemented almost on all the browsers, so this is supposed to be faster as compared to your regular methods of finding elements. So in this example we will again go back to the same page, which is the automation practice switch window page, and I will show you a few CSS selection techniques. The first one is the selection of an item based on the tag name and an attribute value. So before we go to tag name and attribute value, let me show you a function where we just find an element based on the tag name. So this is the method. So what we will do in drivers, in the WebDriver interface, we have this method called find element by CSS selector. Well, this is not on the WebDriver interface. It is available on the actual driver implementation. So on the Firefox, even on the IE drivers, you will find this method called find elements by CSS selector. Now this method will ask you for a CSS locator. Now there are lots of CSS locators. I will send across a link where you will find different ways to locate elements based on the CSS. Now the first in this method, the first thing we can do is we can pass the tag name. I will just pass a tag name and it will find me all the elements which are under that tag. So I will say that I need to have all the div elements. So all I will do is just pass div, and I will store the results back into a list of elements, and I will just try to go through those elements. So just for the purpose of understanding it better, I will dot, and I will pass the driver, and before that I will remove these parts, and you will see that this method will find me all the elements inside on the page which fall in the category of tag name as div. So by default it accepts the tag name first. So I'm just finding the div elements. Let me open my console. This is not the page, it will open another browser. Yes, it has opened the browser. Yeah, this is the browser. I will move it here. It will load the page, and you will see that it started printing all the elements that it was able to find. So you will see that in the class I had said that, not this one, here I had said that find all the elements which have the tag name as div, and then I want to iterate through each element. So this is the for loop, the advanced for loop that in the first class people were asking. So this for loop, what it does, it iterates through each element of a container, so of a list. In this case it's a list. So what it will do, as this is a list of web elements, it will do what it will do. It will, for each element of type web element in the list of web elements, so it will pick up individual elements and it will iterate through till all the elements are done. So what we are doing is we are just printing out the outer HTML just to know the element better. So if I go back and if I look at the console window, I will see that the value of the element is div. It has given me all the div elements. Now it has printed the outer HTML. It is way too long. So this is how you can find all the elements inside a web page of a particular tag type. Now let me expand the code. Now I can put a P here which will represent a paragraph. I can put an input here which will represent all the input tags. So you can take it as a practice, just try to find all the elements, and you will see that this method will be a little faster as compared to other methods. Well, I don't have the exact number in which can tell us like how much faster this method is, but it is supposed to be faster. So now let's move on to the next way of identifying elements using the CSS selectors. The next way is you will specify the tag name and you will specify one attribute of the tag of that element. So in this case, I am trying to find a div element which has a ID equals to content, right? So it will find me the element which has a ID equals to content. Now this is the basic syntax of it. So what you can do, you can even say, I will write it down here, you can even say that I want to find a P element which has the ID as paragraph, let's say, right? And similarly you can find an input element which has ID this, or let's say there is any other attribute inside the input tag, let's say attribute, let's say the name of the attribute is attribute itself. So I will say in the tag name and the attribute which I want to look for. So this is how I have created one such element which has the tag name div and it has a ID content. So if I try to run this program, this method, you will see that it will find that element and it will be something similar to the way we find element by ID, because in this case we are using ID, and here you won't be able to understand the true importance of it because you have just used ID, and find element by ID is a method already given to you in the driver class. So I will show you how it is important in other cases. Before that, let us see how it picks up the elements here. So it will load the page, and meanwhile it loads it up, I will show you that the page is loading, and on the console window it prints out the element. So if I expand it and if I go to the top, you will see that outer HTML of the element is div and ID is content. This was the search criteria that I had given, right? It has to be a division and ID has to be content. And let me go back to the same page, this page, and let me show you one other important feature. So we just found out an element by the ID. Let us get to the element which is represented by this. Just a minute, let me expand it and let me put the element into picture. Now this element, I will have a random ID. This element has a random ID, right? In this case you won't be able to use the find element by ID method because it is random ID. You will see that if I reload the page, let me reload the page, you will see that the ID will change and it goes back to reload. And if I inspect the element again, we have talked about element inspectors earlier in the previous class, so I hope everybody is clear with that. So if I inspect the element again, well, something happened to this. Let me open it again. Yes. So if I inspect the element again, you will see that the ID has changed. So in that case, your find element by ID strategy will fail. You will need something else. So fortunately in this case, we have another attribute called as some attribute, and it has a value of y0, right? So in this case I can use the CSS selection engine and I can tell it to find me an element which is of paragraph type and has an attribute named SumAttrib and it has a value of y0. So if I were to show you how it will happen in the program, let me open the code block. Yeah, so all I have to do is change the string. All I have to do is change the string and say that now I am looking for P and the P has this property. Whereas, yeah, the P has SumAttrib, an attribute called SumAttrib. If I go back, an attribute called SumAttrib, and it has a name, it has a value y0, right? So if I just do this change and if I run this, it will get me this element. Now SumAttribute is not a well-defined attribute for Selenium, right? Selenium doesn't have any method which will find an element based on SumAttribute, right? So in that case, you don't have anything to find these types of elements. But CSS selector comes for a rescue here. You will see that it is connecting. Meanwhile, let me open the console and open them simultaneously, and you will see if I have given the right values, you will see that it has found the element, and it will say that outer HTML of the element is this. It is a P tag, and the ID, of course, it changed from the past run, and it has some attribute which has y0 value, and it found the element for me, right? This is what I want. So a dynamic element which has a changing locator, which changes every time the page loads, I am able to find it using the CSS selector. Now it might have been a little confusing. Any questions?
Virendra, I had a question.
Yes.
The previous instance where you showed us for the CSS selector, where the ID was a constant one.
Yes.
So in those kind of situations, let's say where my ID or a name is constant, what's the best method for me to use? Whether I have to locate an element by an ID or by a name, or is it suggested that I go to CSS as always? No matter what is available or not available, just always go for CSS selector.
Well, the normal thought is that for all the cases where you can get it through CSS selector, do it by CSS selector. Otherwise, do it by the find element by ID and those methods. The reason is, I will give you the exact reason why is it different. Why there are two different opinions. Why we have to use one over the other. So the reason is that CSS selector, CSS is a common standard for HTMLs. So every browser is bound to have a CSS selection engine. So all the browsers will have their own CSS selection engines. So when I call this method find element by CSS selector, what I'm doing is that I'm telling the browser to find me an element based on your engine, right? But in other cases, let's say .find element by ID, what I'm doing is that I'm giving certain conditions to the browser, and I'm telling it to give. So what Selenium is doing is Selenium is itself passing through all the HTML elements and finding the element. So this is the difference. So one is the browser way of finding it, which is supposedly faster than the other methods, and the other method is very much dependent on the browser. Find element by ID. Probably for IE, find element by ID works in a different way. For Mozilla, it works in a different way. So this is how the difference is. The better example would be the XPath engine, where when you try to find an element by XPath, in case of IE, Selenium runs the JavaScript inside IE and then finds the element if you are trying to find it by XPath. But in case of Mozilla has its own XPath engine. So Selenium doesn't have to do anything. It will just tell Mozilla that give me this element and the XPath is this, and Mozilla will return the element to Selenium. So But in case of CSS selector, almost all the browsers have CSS selector, so you can be sure that this is faster as compared to other ones. Did I confuse you or was it clear?
No, no, I got my answer. Thank you.
All right. Any more question? All right. This was one way of finding an element. Consider this as handling dynamic elements also, because we are talking about dynamic elements here. So this is one way to find or deal with dynamic elements. Let's say, so this is the example of the p tag which I showed to you earlier. So this is that method. I will skip this one because we have already seen it. Now in CSS there is one very important feature of wild characters. So let's say you have a string, let's say an HTML has an element, has an ID equals to unique underscore xxxx. So this part, the xxx part, it changes often. So every time you load the page, you will find that this part will change, but unique part is always there, right? So CSS selectors give you a way to identify these kinds of elements also. So, and those are represented by wild characters. So if I just want to get all the combinations, it could be either this or this, or it could be this unique, the changing part, and again a unique string. So these are the different parts that these are the different ways you can have any attribute of an element, let it be ID or anything. It could be in any of these three formats, right? Let's say it's a dynamic element and it has a constant string. So a part of it is constant. So in that case, we have three wild characters that can help us deal with these kinds of situations. The first one is the hat operator. This operator. I hope it's clear to everyone. The hat operator. What it does, it tells that whenever this operator is present, tells that I want to find an element with this tag name and with this attribute name, and the attribute value starts with the text written in this value section. So if you look at this one, it says that I want to find the paragraph which has an ID which starts with 0 point and after that the not constant part. So if I go back to the previous test which we ran, you will see that this was the element, right? This was the element. This element had this part as always changing part and this part as the constant part, right? 0 point will always be there, but after that will be a non-constant part. So instead of writing a different piece of code where you are analyzing the ID for every element and trying to figure out whether it's the correct one or not, you can directly call the CSS selector. Now how do you call it and how it will work for us is this is how you call it. This is the syntax. Now let me run it for you and you will see that it will bring up the same thing. It will bring up the same element, and this time I did not had any need to write extra set of code. All I had to do was just write one liner. CSS selector. You would see that all I had to do was write this statement. So this is a very powerful way of finding an element where some part of the string is constant and the other part is changing continuously. So if I put the console window parallelly and I put the demo window here, you will see that as soon as the page loads, it will find that element for me. There you go. You will see that this time also, earlier it was something 0.4 something, now it is 0.3, but still I was able to find the element. So there you go. In one line you are able to find elements which have some part of the string which is continuously changing. So again, it might be a little confusing. Any questions on this?
I have a question.
Yeah.
In case you have multiple such elements who have the same pattern, then how do you identify that unique element?
Okay.
Because
so you're saying.
Yes, please.
Yeah,
Go.
please. Yeah. So if I'm not wrong, if I am able to understand your question right, so you are saying that there are multiple multiple elements which with p tag and the ID following the same pattern, right?
Yes, yes.
All right. So in that case, you won't use this method. There is another method which is coming up. In those kinds of cases, you will do a relative search, relative position search. So you will have elements with same pattern of attribute changing. So you would, in those cases, you will always go for the position of the element relative to some main element. So we'll talk about it in the in just a few methods down.
Okay.
But the answer is you won't use this method.
Okay. And what is that P attribute there in that paragraph? What is that?
This is the P tag. So if I go back to the console window, you will see that the element that it was able to find had a P tag. So it could be an input tag, it could be any tag. All right, any more questions?
Okay.
All right. We will move ahead to the next method. So here anyone, I think someone has to ask a question.
Yes, this is Mark.
Yes, Mark.
Yeah, the find element by CSS selector, does it has something to do with tag name?
Yes. So
are they similar or something?
So you're saying does it has to do anything with the tag name, this tag name, right?
Yeah, I mean the find element by tag name.
Oh, the find element by
similar.
tag name. Yeah, yeah. So okay. So let me go back. Here. So there is one method called find element by tag name. Now, if you are just searching for using the find element by CSS selector, if you are just searching for a tag and no other condition here, it is exactly same as find element by a tag name. The only difference is that those two internally operate differently. One goes via the CSS selector path and the other one goes via WebDriver path, a different path actually. So the paths are different, but they do the same thing. They get you the elements with the particular tag name. But a CSS selector differs in the get element by tag name in the fact that you can specify other attributes also. You can specify other conditions also. So this is how it differs from PDF find element by tag name.
Okay, so it's much faster than tag name.
Yeah, it is much faster than tag name. Well, to be honest, I don't have numbers, performance numbers to show this, but this is what the general belief is, and which is what makes sense because CSS selection is enabled in the browser. So, but yeah, it is assumed that we can safely assume that this is faster as compared to other methods.
I see. Okay, that's a good answer. Thank you.
All right. All right. So, any more questions on this? Nope. So let me move ahead. So we talked about, let me go back to the console window. So we talked about cases where the starting of the string was changing. Now we could have a case, as explained here, that the end part of the string is changing. Or probably something inside the string is constant and the other parts are changing. So in that case we have another operator, which is the star operator. The star operator, the syntax is almost same. Instead of the hat operator, we are just putting the star operator. The only difference is that instead of finding this string in the start of the attribute value, it will look for anywhere in the string. So it is just a contain check, whether this value is contained inside the value found on the web page, the attribute value found on the web page. Now if I run this method, you will find a similar result. It will find the right element. I will put it here, but I won't run it now. I will run it in one go because it takes time. And I will put FFF triangle here. Okay. Yeah, I will get back to this one, and I will fix this. Actually, this is the method name. Okay. So we will run this method and we will see the results. Let me move on to the next while character that we have. The next one is the $sign. The $sign tells us that I'm looking for a value at the end of the string. So here it will find, okay, well the example here is wrong. I will correct the example. So it will find out whether the value is present at the end of the string or not. So if it is present at the end of the string, it will find the element, otherwise it won't find the element. So it works similar to the previous methods, but this time it's just the end of the string. We can run it, or probably you can run it at home. I will share the project with you and it will explain to you how it works. So this was pretty much it about the CSS selectors. Now CSS selector is a very big field. It has lots of other ways to select elements. We have a topic coming up on our website. I will share the link to you guys, or you can do a Google search and you can find more ways to finding elements through CSS selection. But these are the major ones, and these would suffice as of now. And if any unique thing comes up, we can talk about that particular element in those classes only, just to save some time here. So this gives you a basic idea of CSS selection. Any questions in this one? All right. So this was about CSS selection. We will move on and we will look at other topics that we have. So these slides just show you all the different topics that we discussed about. So it talks about these three operators that we had. Then the hat operator that we had. It gives you the syntax also. Just take a look around. So it tells you that there are other CSS features which you can Google through, or we will share a link with you. And if I move on, let's try to find out. So there was a previous question in the last class that was finding dynamic elements, or if I generalize the topic, it would be different strategies to find elements. So the elements can be really tricky on web pages. If it's a static web page, then probably there is no problem in finding an element, because you know that it will always be there. Now the problem comes when we have any of these conditions where we have to follow any of these rules. So the problem comes when there are elements which are delay loaded on the web page. For example, some element comes quite late on the web page. So in that case, you might have to wait for the element for a specified amount of time. Those are called delay loaded elements, and they can come up on the page based on some JavaScript call, or probably Ajax call, or probably a DB call, where the DB returned the result quite late, and that's why the element weren't created. So these are a few reasons why an element can delay load on your page. Somebody, okay, yeah. So So that's how an element can delay load. So we will talk about some strategies about delay loading. So let me pull up the right project, and yeah, this is the element find strategy. Don't worry about the code, you will get all the code. So I have divided it into sections. So you will see that the sections have regions defined, and the region will talk about the particular problem that we will be discussing. So the first one is delay loaded elements. So if I talk about delay loaded elements, before that let me go to my web page. Let me show you what a delay loaded element looks like. Before that, let me just close all the windows. So what we have created, what we have done is we have created a web page. This is the web page. Sorry about that. This is the web page. On this page, you will see that at the bottom of the page, let it load. Yeah, at the bottom of the page, you will see that there are a set of these elements that pop up, right? So it was new element 0, it was new element 1. So it will pop up till we have 5 elements on the page. So these are delayed. This simulates a situation where we have a delay loaded element, right? So just give me a minute. Let me mute the person where we are getting this noise from.
I've done that, Virendra.
All right. So, all right. All right. So this is the page where you would like to go, and these are the elements. Now, if we inspect these elements, so the first thing you will do is you will try to inspect the element, right? So you will see that all the elements are same, right? All the elements have the ID as target. But the problem is that once the page loads, they don't appear on the screen till 5 seconds have passed, right? So after the first 5 seconds, I will show it to you. This is, yeah, so you will see the element is not present, but after 5 seconds it comes up, or let's say after X amount of time it comes up. In those cases, what you will do? So there are 2 ways to handle it. Write your own code to synchronize the situation. By synchronization I mean wait for the element and continuously poll for that element's existence. By polling I mean continuously query the web page for the element's existence, or depend on the waiters provided by Selenium. Now the waiters provided by Selenium are very elegant solutions which require just 1 or 2 lines of code and it will work. And if you write your own code, it would be little elaborate, but it will give you a basic understanding of how to find these elements and how those Selenium give the inbuilt Selenium weights work. So it will give you a comparison between the two. So we will go one by one. We will first see how we can do it by ourselves, and then we will see how they do it. So before we go into this, yes, so this is how we do it. Now before I do this, I will show you that let's inspect this element, and we will see that we have a ID equals to target. So I have kept it simple because we have already studied how to find elements which doesn't have a unique identifier. So right now it's just a unique identifier, but you may find a situation where there is no unique identifier. So you have to use your knowledge that we learned a few minutes ago to find those elements, but the basic theory will remain same. So what happens? So in this method, what we will do, we will, let's say this is an element, and let's say the requirement is that it appears within 5 seconds. So you have a requirement on your web page. Let's say that there is the stock price element which is showing the stock price, and the requirement is that this element should appear within 5 seconds of the page load. So the upper bound is 5 seconds. So what we can do, we can create a simple program where we will just check when the execution started, and after that I will create a while loop. I will create a loop where I will continuously poll the element till the timeout is reached. The timeout is like the number of seconds or minutes I have to wait as per my requirements of my application. Number of seconds I have to wait. I will continuously keep a loop till that time, and I will continuously try to poll that element. And you will see that every time I poll the element, it might be possible that element is not present there, right? Because actually the element won't be present there. It's a delay loaded element. So I will catch that exception. I will log it. I will move forward, right? This way I'm able to log it, plus I'm able to move forward, and I will put a sleep. Let's say after every couple of seconds, I will again poll the element. So I will do it till the time either the timeout has been achieved or the element is found, right? In this loop, I haven't explicitly shown you to break out of the loop, but I will show it to you right now because I wanted to keep it like clear. So this is the very basic method how you implement it. You create a while loop, you start and you wait till the timeout is received, timeout happens, and in every loop you check for the element, you try to find the element. If the element is not found, you catch the exception, you wait for some time, and you again run the loop. So I think it's self-explanatory, this code, but I will ask for questions. Do you have any question in this one? Because I will show you how it runs in real time after this. Okay, no questions. So this is one way of finding an element. Now let's say, but the problem with this is it will keep on looking for the element till the timeout is received, because there is no way to break the loop. So what I will do, I will say that every time you find an element, put it inside this variable, put it inside this variable, and if this variable is not equal to null, just break out of the system, break out of the while loop. So what will happen is now it will keep finding this element in a sequence, and as soon as it finds the element, it checks whether the element is null or not. If it's not null, it means it has found the element, and it will break out of it. It will break out of it and it will return the target element. So this is one way of finding it. Before I run this program, any questions on this one? All right. So let us run this thing, and let us run it without breaking. So in the main program, I will call this method, and you can run the CSS selector part at home. Okay. So it is element and I will try to find, I will give the web driver, which is ff driver. So I have created a method. You may choose to not create a method. You may choose to create a method which has more arguments to pass. It completely depends on you. So if I go back, the element ID is target, and let's say I want to wait for 3 seconds before finding this element. So I will run this. This is a very coarse way of finding it, the very basic way of finding it. But yeah, it's one way of finding it, so it's quite required that you understand it. So it opens up the page, and I will show it to you. So you will see that it's trying to find the element, and as soon as this element pops up, it says that it breaks out of it. It says that I found it and I will move out of it. So this is one way of finding the element. You can create a generic method. You can create a generic method where you can pass on just the element locator and the type of locator it is, whether it's a ID or a class name or a simple name, and you can specify the timeout. And the method is method should be implemented in such a way that based on whatever ID and whatever locator type and whatever locator value and whatever timeout specified, it runs a relevant loop. So right now we have made it generic to find element by ID only, but you can change it based on your requirements. So we just saw it in action. We just saw how it waits till the element is visible. Any questions on this? All right.
But in this case,
Yeah.
we could see the target, right?
We could see the target.
Because you're actually looking for target, and if you go to the your website, you can actually see the target because it has every time it's occurring the same thing.
So, okay. Mm-hmm.
If you look at the href and the ID for class entry share, if the ID is same, although the name of it's called new element 0, 1, 2, 3, 4, 5, 6.
Just a minute. I think. Okay. Okay. So let me go back to the page. You are saying that it says new element 0, 1, 2, 3, 4, 5, 6, right? These are the elements.
Yeah.
Yeah. So you are saying that the ID is same.
Yeah.
Can you come again with the question?
The question is like, you're trying to see in the output you want to see when you see the target, it should run, and if it's not seeing the target, it should come out of the loop, right?
No, I'm saying that till the time it doesn't see a target, don't come out of the loop.
Okay, I'm sorry, my mistake. Sorry.
Yeah. So yeah, I think I wasn't clear. So I will explain to you again. So it says that either the element should be visible. So in this case it's not coming out of the target. Yeah, so this is the case. So in that case, okay, yeah, I think I missed the point. So what happens is that when I comment this out, so what is happening that it will keep on searching for the target, the element, till the timeout has been reached. So it will keep on searching for it. So whether the element is visible or not, it will keep on searching for it. Yeah, so I think I showed you the wrong example. So if I put this, you will see, if I put this and if I run this, what will happen is this: as soon as the target element is found, that means it's not equal to null, it will break. So earlier we had like around 4 or 5 times it looked for the element, and this time it should look for lesser number of time. Earlier it was like 6 times it looked for the element. Yeah, so if I just move it here, and as soon as I load it, yeah, as soon as I go back, so you will see that it's keep on searching for it. As soon as it appeared, it went out of it. Well, again, it's quite a number of times, but you know that it came out when it found the element, because this is how we have programmed it. Probably I can put down some other condition, some other statement here. I can say, just to be sure that it came out of it, system dot okay, so if I run it this time, so it will print that once it has found the element, this is D. Let me just put it this way. So it's just how you would like to synchronize it. Either you keep on polling it, and this is the only way actually you can do it. The only difference is that you do it via the WebDriver way, the weights that they have provided. So this is the page and it's loading, and as soon as it loads I will pull it down. Yeah, so you will see that it will keep on doing that, and as soon as the element came in, well, I think I made a mistake somewhere. Target element not equals to null. Did it show that? Okay. Let's create it for 6 seconds. Yeah, well, I think the timeout was small. That's why it didn't fall into this. It broke out of it earlier. So right now I've increased the timeout and it will wait for 6 seconds. Probably it wasn't waiting for the exact amount of time. So if we run it again, but the idea is simple. You have to poll for it till the time you find it, or you break out of it if you don't find it in the required amount of time. Yeah, so it was the timeout. So I've increased the timeout, and you see that as soon as this element comes in, it says that I have found the element and it breaks out of the loop. So this is the basic idea of finding an element which is dynamic in nature, which appears quite after some time on the web page. Any questions on this? Because I'm sure there would be some questions here. Srini, does it clears out your doubt?
Yeah, because I was just confused on the way why we were using target, because the target was actually repeating every time, so I was in a confusion there, but now it's clear.
It's clear, right? Okay, so I think Usha and Snehal has a question.
Yeah, Virendra, the time. Okay, maybe I'll talk. Yeah, the timeout parameter that you passed to the method, is it the maximum time for which it has to wait to call the element? I mean, what is the timeout there?
Okay, yeah, so the timeout is the maximum time it has to keep on polling for the element. So the maximum amount of time, let's say if it's 14 seconds, so it will poll for the element, it will look for the element at least 14 seconds, at least for 14 seconds. If it's able to find the element before 14 seconds, it will come into this part and it will break out of it. So this is 14 seconds, it's the total time. So it's a total time, the total time is 14 seconds. Now after how many seconds it has to again try to find the element is defined by this method, this sleep. So it is 250 milliseconds. So this is the polling time. I'm sorry, I confused with the 2 times. This is the polling time. So after every 250 milliseconds, it will try to find the element, and it will try to do so till the maximum time, which is the timeout. And in between the maximum timeout, if it's able to find the element before that, it will break out of it. Does it clear it?
No, maybe I'm a little confused. If you could just explain once again.
Okay. Yeah, sure. So we have given the timeout value, right? So this timeout, okay, I will explain it here only. So this timeout says that try to find the element on a web page for this much amount of time, at least this much amount of time. So let's say it's 14 seconds. So my test, it will try to find the element on the page at least for 14 seconds. Now, within these 14 seconds, I'm continuously trying to find the element. I'm continuously querying the element, querying the HTML page using this command, right? Now, this command, after how many seconds this command should execute? It should execute after 250 milliseconds. So in 14 minutes, 14 seconds, there are like 14,000 divided by 250 milliseconds, right? So that many number of times it will try to hold the elements within the 14 seconds. If it's able to find the element before that, it will break out of it. Is it clear? I think I confused you.
Yeah, it is. No, it's okay. I was able to understand now.
Yeah, so if you look at the code at home, you will understand it. So it's not it's not that hard code right now.
Yeah, okay. Yeah.
Snehal, any questions?
Yeah, so every time the element was not found, it was going in that exception block of yours and it was catching it, right? Okay.
Yes.
The other thing is that on your web page, the HTML, when you showed us, there are multiple target locators there. So
Yeah.
which one does it identify? Because you are searching by ID, I believe, ID equal to
Yes.
target. So which one is it identifying? Because there are multiple target IDs there.
Okay, so the find element by ID has a property that it returns the very first element. So it will return this element, the very first element.
Okay, okay. So each time it will just look for the first element only.
Yeah, each time it is just trying to find. Okay, so I think you missed it in the last class because of the connection issue. So there are two types. The first one is driver dot find element, right? So these are the find element types. You will see find element. Now they have a corresponding find elements. So this is a plural, this is a singular. So find elements finds out all the elements on the web page meeting the criteria, and find element finds out only the very first element that it is able to find and returns after that. So find element will try to query the HTML DOM and it will reach to this place. As soon as it reaches this place, it will come out and it will return this element. But find elements, it will go through the HTML DOM and it will find all the elements and it will return a list of the elements. So yes, right now it is finding the first element.
Okay, okay, fine. Thank you.
I have a question, Viren.
Yes.
See, when you're using find element by ID, you are finding it inside the ID A, but none, nowhere we have specified that we have to go explicitly and find out inside the ID A, because there are other IDs also available on the page.
I am sorry. Okay. So you are saying that I haven't specified whether to find it inside a A tag or a P tag or any tag, right? Right. So the find element by ID will look for any element with that ID. Let's say there was a P element with the ID target on the web page, and that element appeared first in the page, so it will return me that element. But the property of ID is that it is supposed to be unique on the page. So you will never find that the same ID is present for a P tag and for a A tag. Well, the standard is that it shouldn't be same.
Okay, but in this specific case, where are we taking target into consideration? I mean, because the locator that we have used, where is it specifying that we have to?
So while calling the method, we specify target.
Okay, yeah. Sorry, I missed it.
Yeah. All right. Any more questions? Okay. So we will move forward. So basically, in this exercise, what we came across is that in case of elements which any question? Okay. So with this particular exercise, we took our time, but with this exercise we came across a very important point. So the main reason, the main features that we are looking for while finding a dynamically appearing element, finding a delay loaded element, is first time to synchronize. We have to know how many minutes or seconds that we have to wait till the element is visible, or how many seconds or minutes we have to wait till we can safely consider that the element is not visible or there is a bug. So this is the time to synchronize. Then we need to know time interval after which we have to query the element again. So polling time. It tells us that after how many seconds I have to keep on polling for the element. Then after that we come across another important point is that while finding the element, what are the exceptions that we have to ignore? Because we know that it's a delay loaded element. We know that it will appear late in the system. So while finding it, we may come across no such element exception or any other exception. So we should know what are the exceptions that we have to ignore. So these are the three things that we have to have prior to writing our test method of finding a delay loaded element. So yeah, so now with this example, this was a very generic example. You can create your method, whatever method you want to create, a more generic method. Now after this we will move on to very specific example. We will use another method to find a delay loaded element, and the other method is using the thread.sleep method. So here in the previous method we were continuously polling for an element. We were continuously polling after every 250 milliseconds. We were trying to find the element on the web page, right? Now there is another method where we can specify a fixed amount of time. Let's say I specify that I will wait at least for 4 seconds, and I will do nothing in those 4 seconds, and after the 4 seconds are over I will try to find the element. So this is very non-deterministic way of finding the elements, delay loaded elements, and it is not recommended. But just to show it to you, we can put a thread.sleep. What happens in this case is that all the functions of the test program are stopped, and the program goes to sleep for 4 seconds. When it comes out of sleep, it again queries the web page and tries to find the element. If it finds it, it's good. It will return the element. If it doesn't find it, you may catch the exception and you may move forward, or you can do whatever necessary steps you have to do. But this is a non-deterministic way, because at least for 4, now because not at least, because at least for 4 seconds your system is in sleep. You can't do anything. Contrary to the previous example where as soon as we found the element we broke out of the system. So here at max we will go for a timeout of for a timeout of 4 seconds if the 4 second was the timeout. At max we will go to 4 seconds, or if the element is found before 4 seconds we will come out of it. So this method is more deterministic, and the thread.sleep is not deterministic method. So this is the main difference. So we don't recommend using thread.sleep, and I will show you here in the class. You can just go through this method later on. So after this, any questions on this before we move forward?
Yes, I have a question.
Yes.
Yeah, with regards to delay loaded elements, like, is it applicable for a progress bar?
Yes, it is applicable for a progress bar as well. So in progress bar, you will see that a progress bar, at times it's an image, right?
Yeah.
So that progress is an image, and that's a sequence of images, because it has to show some animation. So it's a sequence of images. So if you are constantly changing the images, you can identify each image because it would be a different URL, and each image is loaded after some time, right? After a few seconds the second image will load, after a few seconds the third image will load. So you can use the same logic to wait for each image to load, and just copy the URL of the image and later on compare. So this definitely follows for the delay loaded, the progress bars as well.
Oh, I see. the delay load element thread slip?
I'm sorry, Mark.
Is it for the thread slip applicable also?
Thread.sleep is applicable, but in this case, for those 4 seconds, you won't be able to do anything. So the logic where you have to identify each of those sequence of images, you won't be able to do anything with thread.sleep. So this might not work out for you. So the only case it will work out is that you don't care about the progress bar. You just know that after 4 seconds, the progress bar will go away and the element of the desired element will come into the picture. So you can just ignore. So for ignoring the progress bar, this is fine, but not to test the progress bar.
Okay. I see. Okay, thank you.
So Asif had a question. The question is, last time we had Firefox version 32 that was showing a problem to us, and the problem with Firefox is that it updates itself, and the latest version is not working. So how did I fix this issue? Well, yeah, this is 31. So the problem with Firefox is that if you load Firefox in a different profile, it will automatically update Firefox. And to avoid this situation, what you can do, I recently figured it out. You can first install the older version, any of the older version, and then once you install it, so once you install it, go to this path, Mozilla Firefox, go to this path. Even before opening the Firefox after installation, don't open Firefox after installation because it will update itself. After installing the Firefox, go to this path, C program files x86 Mozilla Firefox, and here you will find the updater.exe. As I have deleted it, you won't find it here. So here you will find the updater.exe. Just delete that file because that is the one which is responsible for updating Firefox. So once you delete it, it won't update. I think Asif, you got the answer. Any more questions on this one? All right. Any more questions, or we should move to the next topic? Okay, moving on to the next topic, which is changing element property. Now, this is another important type of elements that you see on your web page, and this is like the most common that I have seen. So most of the time your application will have a continuously changing element. Some property of the element will change continuously. For example, your web page might have a clock, right? Or your web page has a stock bar which gives you the runtime stock price. So it keeps on changing after every few seconds, right? So you want to test those kinds of elements, or you want to wait on those elements till the specific value is reached, right? Let's say you want to wait on a stock price. You want to test whether the stock price, if updated from the DB, reaches a value of 32. So how will you wait on that? So again, the idea is same. You will continuously poll the system. You will continuously poll the element, and you will try to see the value just when it reaches the point, like whatever the condition you have. So I have created a few methods. The first one is continuously polling. Now these are our defined methods. We have a separate elegant way, which is the WebDriver way, but this is very important to understand the basic implementation, how it works. So it will give you thorough understanding of how the driver weights come, because driver weights work, because in real time you would be confused otherwise. So the point is that I want to continuously check a variable, an element. So in our on the same page that we have, I have created a clock. So clock is also a good example. So I have a clock, and this clock, this timer, actually not a clock exactly, but a timer. This timer keeps on decreasing for around 40 seconds, and it reaches a point where it displays it, instead of a number, it displays a text called buzz. So this could be a situation similar to your stock value reaching to a particular point. So here I would like to test whether my whatever this element is, it reaches a state which is buzz. And once it reaches the state within the specified time, I will consider my test as a pass, otherwise I will consider it as a failure. So you will see that it has just reached buzz. So the basic idea will remain same. You have to continuously poll the element, right? And this is basically the only way you will do it in your tests, because either you use WebDriver weights, it will do the same thing. Either you use your custom methods, it will do the same thing, because this is the basic idea. So again, we have these 4 points. We have to know a way to identify the element. We have to know the time limit till which we have to keep querying the object. We have to know the polling time, which is like after how many seconds I have to check the value again. So in our case, this clock, it changes a value after every 1 second. But in case of a stock exchange flyer, you might see it changing after every 3 seconds or 2 seconds. So you should know the polling time. Now after that, the fourth condition is that you should know the condition when to stop searching for the element. So this condition could be your failure condition or the pass condition. Let's say in our case it is, as soon as the clock says buzz, I am good to go. And the condition is that the clock should say buzz within 40 seconds or after 40 seconds. So our duration comes out to be 40 seconds because we want the maximum timeout to be 40 seconds, and the polling time comes out to be 1 second because every 1 second it changes the value. So again, the same thing, we will first find the element, because as it is not a delay loaded element, it will be present there. It's just that one of the property of the element will keep on changing. So if I go back here, if I load the page again, and if I just query this element again, try to see what this element is all about. You will see that it's a clock, and you will see that the value is continuously changing. Look at this. So the text value is continuously changing, right? And this is your test condition. This is your test environment. So what you will do, you will first find the element, because element will always be there. The ID is clock. It could be anything else. Instead of ID, it could be any other attribute. So you know how to find elements based on different attributes. So you will find the element. You will again create your own timing conditions, which is you will measure the start time, and you will wait for the timeout to happen, and every time in the loop you will get the text of the element, which is this value. This is the text value. So you will get the text of the element, and you will verify whether buzzword is inside that text or not. If it is there, you will say you who buzz found, and element at this moment is, you will print out some other important information. Otherwise you will keep on querying it again. So I will run this method, and you will see how it works. Continuously pulling. Let me close this window, and I will run it again. And when I run it, I will open the console window. And you will see that as soon as the page loads, okay, and you will see that the clock is ticking, and you will see that our test is trying to compare, trying to find the element, and you will see that whatever value is here, you are getting it here. So it is continuously polling it. it is waiting for that buzz word to come in, right? Either it will come in the specified time, which will be a pass condition, or it will fail to come in the specified time, which is the fail condition. So this is how you test the dynamic elements which keep on changing some of its property, the property of interest, continuously. So you will see as soon as the buzz word comes in, it bails out of the loop and it says yoo-hoo, buzz found, and your test passed. Right. So again the same logic, but a different way of implementing it. Actually the same way of implementing it, but little different conditions. So this tells us how you can test elements which have continuously changing values, and unfortunately or fortunately that changing value is the value to test. Any questions on this one? This is the code. Any questions?
Yes, I have a question.
Yes.
Now, we know that it will, after 60 seconds, it will display the value buzz,
Yes.
and we are polling after every, let's say, 2 or 3 seconds. So,
Yes.
so once the polling starts, when the loop iterates, when it goes to the next item, I mean, if it's for 2 seconds, then why does this current time millis, how this condition is satisfied? I could not understand. While start time,
Okay.
mainly this, how this while condition is getting satisfied.
Okay. So probably you are not able to understand the statement, right? This one.
Yes. Yeah.
Okay. So yes. So system.current time milliseconds. It says the time in milliseconds. What is the current time in milliseconds? So from the start of the day to this time, it will convert the units into milliseconds and it will store it into this variable. So this will be the start time. When this statement will be executed, it will store that millisecond here, and after that it will subtract the current time from the start time, and it will verify whether the time difference is equal to time to wait or not. So if it's not equal to time to wait, it will keep on executing the while loop. If it is greater than or equal to time to wait, it will come out of the loop. So it's just a mathematical comparison here. Start time minus current time.
Okay. Okay, I understood. I was thinking, why are we not incrementing the time? It's actually it's taking from the system, the current time.
Yeah. It's the clock.
Okay.
I have a question. When you say start time minus system current millisecond, would the value be in minus?
You're saying whether it should be minus or not. I'm sorry, Asif, your voice was...
Time, which is like right now.
Asif, your voice is
Yeah, that's
breaking.
right.
Could you write it down for me?
Sure.
Yeah. Meanwhile, Asif writes down the question. Any other question?
Yeah, I've got one.
Yes.
Okay. During the starting of explaining this find element, you said that there are two ways to do it. One is either by driver and second is either directly to the browser. Is that what you said?
Either by a driver or either by writing your own code to synchronize the finding of element.
So the code which we have written right now, that exactly goes in the find driver. Is that correct? Like when driver searches it, or is it any different?
Yeah, it is different. So actually, yeah. So let me correct what I said. So actually, I think you misunderstood a little bit. So what I meant was, probably I wasn't right in explaining it. So what I meant was there are two ways. First, you write down the code to synchronize your test based on the state of the element. You write it yourself, or you use the weights given by the driver. Now this code, whatever we have written, driver weights have implemented similar structures, so you don't have to write all this, but inside they are doing the same thing. So you don't have to do the weight. You can directly use their methods and you can do the same thing.
And what would their method be? Like, what are they called, if at all I have to call them?
Those would be okay. So let me show you. Those would be the weights. There are many types of weights that we have. So let me go to.
So Biren, are we going to cover those topics as well?
Yeah, we will cover those topics. So after this, we have weights in line.
If they are coming in this session, I'm okay with that.
Yeah, they are coming in. Yeah, definitely. So
Fine.
they are coming next. So what we would be doing is we would be using fluent weight, which is one way of expressing the same scenario, right? Then we would be using just a minute. Then we have other methods also. We have WebDriver weight, which is somewhere here only. Yeah, we have those coming up. So one is the fluent weight, and then yeah, this is the WebDriver weight. Then we have other weights in the support.ui namespace. So they are coming up. But just to explain the whole concept of synchronizing your elements, what you are trying to achieve, is why we wrote these programs. So basic idea is to just get really comfortable in what dealing with a dynamic element looks like.
Yep, got it. Thank you.
All right. So yeah, so Asif asked a question which is start time value is going to be smaller than the new system.current time in milliseconds. Would the condition be negative as start time will be smaller than the new system time? Yes, well I think that's true as it seems here, but I think that would be just a mistake. Let me get back to that element first, that method. So we were doing this, yeah. So the question is that start time will always be smaller than the current milliseconds, right? So yeah, probably that's right, but I have to check it again because I verified it and it was this was smaller than this one. I think the way they count the time. So yeah, it could be the other way around. It could be system.current time in milliseconds minus start time, but I think this is the right one. Start time is smaller than the current time in is greater than the current time in milliseconds. I will just check it out, but yeah, the basic condition remains the same. We have to find out whether the time difference from the start of the test to till now is smaller than the time to wait. Okay, yeah, so in our previous example it was the other way around. Let me see it. Yeah, you're right, Asif. So Asif is saying that in the previous example we have subtracted current time from the start time. So yes, you are right. Probably that was a simple mistake there. I think I will correct it and send it across once I'm sending it. So yeah, that's right. That's just a mathematical equation. Once you will understand what the system.current millisecond does, you will be able to design your own condition. So thanks for pointing it out. I will correct it and I will send across the updated one. No questions anymore? Okay, so we have just overshot the time. We weren't able to complete everything today. But yeah, I will just take you through the next topics that are coming up. The next topics would be nested elements, where we were talking about how we can find out nested elements where one element is inside the other element. If I go back to this example, the same page, in the next class tomorrow we will talk about nested elements, where you will see that elements are located deep inside the hierarchy. So in the first div there is another div, and then after that there is another div. So in here we will talk about two basic approaches, which is the relative way of finding it and the absolute way of finding it using XPaths. So we will talk about that. We will talk about XPaths also in the next session. And then before going into these, we will talk about driver weights. We will talk about different types of weights that we have, and we will also talk about two important concepts, which is the concept of functors, which is functions and predicates. So all the WebDriver weights, especially in the support.ui section, I think in the support.ui namespace, all the weights, they accept function pointers and predicates. So before going into that, we will talk about what generic functions are and how we can implement them. So this is pretty much it what we will have tomorrow. Any questions on today's session? I know this was quite code intensive, and it was it might have gotten quite confusing.